So I'm not going to do node. I'll do that simple circuit technique. So when I look at this guy, I'm really just sort of like following the currents. So if I have the current here, I'm assuming that the current's going to go in that direction. So I'll label that 1. And then the current splits here, and I should get 2 going this way and 3 going that way. But if I look at this node right here, we already know that there's no current there. So then the current has to go from here all the way to there. Let's call that 4. So one of the things that we immediately see here, if this is ground right here, that's ground, that means that I have a current going from ground to that node. That immediately tells me that whatever that output node V naught is, has to be negative. Okay, so what I'm saying here is that if I look at this node right here, this tells me, if I look at right here, this implies that V naught is negative. So if I get a positive number, then I know that I have to have done something incorrect. So if I look at this, since I seem to like using x as a node variable, I'm going to continue to use x. So I'm going to say that this node right here, I'm going to call Vx. And this node over here has to be V naught. Right? That has to be the naught right there. So what I want to do here is I want to then go in and I want to focus on just following the current. Okay? Just following the current. So if I look at the current here, right, that current I3 tells me that so I could do a couple of things. There's several ways to solve this thing. So if I look at the first node, so note that I have I1, has to be I2 plus I3. That's one thing here. And we also know here that if I look at this voltage, if I look at this current right here, so let me focus on I2 and I4. So if I apply KCL essentially at this node, that means that this current must be the same as that current. Okay? So then what I'm doing here is that I'm applying KCL. So if I look at that, that means that the current I2 must be the same as the current I4, which then means Vx minus 0 has to be the same as 0 minus VO, which immediately implies that Vx must be minus V naught. That's good, right? We expected a sign change right there. So what I did here is that I followed the current just going along this branch. So now what am I going to do? I'm going to go around the other branch here. Now all I'm going to do is that I'm just following the current. So now I'm going to focus on I1 equal to I2 plus I3. I think I was jumping around in my head too much. To be honest, I'm kind of rusty on these things. We haven't been talking about them in a while. So if I look at this guy, so I got to follow the current. So I'm going to look at this guy right here. So if I look at I1, I should get 10 minus Vx. Now note, I'm dropping all the 1Ks. Right? We know that the currents are going to be milliamps, so I'm dropping all the 1Ks. And then that current has to equal I2. Well, we know that I2 has to be Vx minus 0. And then I3 has to be Vx minus V naught. But I know that Vx is equal to minus V naught. So now I could solve for Vx. So now solving for Vx, what I'm seeing here is I'm going to get what? That Vx I'm taking to the other side, so I'm going to get 10. Okay, so that's this term right here. So then I get this term right here. And then this guy should be Vx minus Vx should give me 2Vx. So this implies immediately that Vx has to be 10 divided by 4, which should be what? 2.5 volts. Now I know what Vx. But that immediately tells me here that V naught, which is minus Vx, should be minus 2.5 volts. Okay, so we got our first result right. So now that I know what Vx is, I could then go in and solve for this current here. Oh, this is a slippery current. So let's see here. So that means if I'm going to calculate I naught, note that 3 and 4 are coming in to that node. They combine and they're coming down this branch. But then I have the current coming up because I know that is that's negative 2.5, so the current has to be coming up here. So if I was to do this in color here, what I'm really looking at is that I'm looking at this current right here. Then I'm looking at that current right there. And it's that current plus that current that gives me I naught. So if I was to sort of like label these, right, just to be clear, so if I did 1, 2, 3, 4, then I'll call this 5, and I'll call that 6. So if I look at this, so then I'm going to apply KCL at output node. So if I apply that at the output node, then that means I should have, right, I naught should be I5 plus I6. But what's I5? I5 has to be 3 and 4. So then it has to be I3 plus I4. And then I6, well, it's just got to be I6. So then if I look at using Ohm's law, and seeing I3 has to be Vx minus V naught, but that's just twice the value now. Right? So this has to be Vx minus V naught, and then I4 has to be 0 minus V naught. Oh, yeah, right? V0. Sorry. And then I6 has to be just V naught. Now, we got to be careful here because note, I'm already adjusting for the positive value, right? Technically, there is a minus here, but they all cancel out. So if I just use the numerical value here, so this guy here should give me, what, 2.5. This guy here should give me minus 2.5. And then I'm going to get 2.5. So these guys cancel to 0, so therefore, that tells me that I naught must be 2.5 milliamps. Okay. So note that I was sloppy with my minus signs. Right? Listen. Yes.
It should be 2.5 minus negative.
Yeah, it should be 5. Yeah, the difference between Vx and V naught is 5.
Let's see, let me make sure here. So, oh, I forgot the 2 here. There's a multiplication of 2. Thank you.
Wait, no.
Right? Because that is the sum of 2 of them.
Yeah, that's right.
Yeah. Okay,
Right?
okay.
So then that gives me 5 minus 2.5. Right? No. Yes.
Yeah, minus 2.5 plus 2.5.
I'm getting confused with the minus sign. Let me step back. Let's be more careful here.
Why don't we just use I3 plus I4 equal I1?
Say that again?
I3 plus I4 is just I1.
It's just I1.
I1 divided,
Wait, let me see. I3 plus I4 equals I1?
Yeah, I want.
I1 on the left.
I5 has to be I1, right?
Okay. Quit being a smart ass, because that's absolutely right. Right? I should have done that right away. I totally agree. Yeah, that was poor choice. Right? Instead of messing around with the sign, I totally agree. So, you know what? I'm going to erase this mess. And I agree that this guy has to be I1. So if I do that, then I don't have to consider all of this as I1. So then if I look at just I1, it's got to be 10 minus 2.5. And then this guy has to be 2.5, so it should give me 5 milliamps. Nope, that's 10. It should give me 10 milliamps, excuse me.
V naught is negative 2.5 though, so it should give you 5.
I agree, but what I did here is that voltage is this way. But if I switched it up, then it should be a positive 2.5, right? So I agree that this is, so I naught is 10.5. Okay, thank you for that.